Hello, this is the instruction of how to install the Excel XPS macro in Macintosh Excel 2016. If you have a zip file download from the Dropbox, you can extract somewhere else on the desktop now. You can see inside there is data. This is database file for binding energy for XPS and chemical shift and photoionization cross-section. I can also put some X-ray absorption coefficient and all the electron energy included. All the file I extracted from the references you can see from this text file. So each file we can have references, so you can download by yourself and put your database into the macro. So this already made a database by myself, so you just copy those files into specific position. We will show you later. And the instruction include some PDF file for instruction installation on Windows, Macintosh, and how to update the Excel macro to latest version of the code. This is the instruction, quick reference for the command we can use in our Excel macro, some technical note and release note there. Hands-on data also available here. I demonstrated in the workshop last time. And there's a most important part is the code. You can open with some text editor, any. So you can copy all the code into the macro later. I will show you. The sample included some data measured at our beamline 3.2 UA for photo emission spectroscopy. Then we first show you some instruction first here. So this video only show how to install the macro on macOS Excel. We will make a Windows version later. So you can also follow this instruction, but if you want to see the video, I would like to show from now on. So open Excel first. Open blank workbook. You will see here. First of all, we like to show the developer tab. There is no developer tab in the default Excel configuration. From Excel preferences, you can see some option. You can see the view and the ribbon show developer tab here. Turn on and close. You will see the developer tab here. Click on, and you see some option. You can see the record macro. Click macro, and the personal macro workbook. Any name, start recording. Okay. Okay, and just stop. Without do anything, you will see there's a macro here. If you want to see inside, no. Okay. Cancel. Click the Visual Basic macro. You see this VAB project modules, module 1, double click. So you can see that this personal macro workbook startup every opening the Excel application, delete inside any code, and you open the code inside the macro. Select all the text and copy and paste into this Visual Basic Personal Macro Workbook. Here, Module 1. You will see, scroll up the top of the editor, show that option explicit. There's nothing before this, and you will see all the code I wrote, and there's some option here, but you to notice that this is the database location for the Macintosh and the database position for the Windows. Now we are setting up the database for the Macintosh, so you have to follow this address and copy the database file I show here into the position of the database here. So how to access to the special folder for database? You can click Go and click Option here. You can see the library. Without press Option, you cannot see. So you have to press Option key and click Library. And you will see there's under the library, there's a many folders, and you can see group containers and UBF 828346 G9.office, and under this you have to make a new folder, any name, but I use the Excel folder. Okay, so this is also specifying the code here. So below the my Excel folder should be there's a data folder. So the copy, how can copy that? So I just register this folder into the quick access menu here. So you click the my Excel folder, you can immediately show inside. And what I have to copy is just all of here. Copy and paste into file item. So this is the data folder. Every database already recorded here. And if you want to see something instruction, you can also see that folder here. Next thing, we have to put some shortcut key, Option Command E, so you can call anytime you want to get this macro on the data. You can call the command Option and E. The other thing is Excel add-in, solver add-in. You have to deploy the function to fitting the data based on the macro. And the Visual Basic editor also activate the solver here. There's doesn't show any checkbox, but there's already there. I believe that is on. Save the Visual Basic and quitting the Excel. So I would like to open some example data, open with Excel here. Okay, and I specify the shortcut key command option E. And this is the goal spectrum. So I put the goal the end. So you can see here standard value from the database. But our spectra shift from the standard one, so due to the beamline calibration or sample condition, then update the binding energy scale close to the standard reference one, and you move to the fit sheet, command option E for the fitting. Okay, so 2 peaks, doublet peak, amplitude ratio 4:3, 7/2 to 5/2. The binding energy difference between the two doublet peak is 3.6. This is specify some code. The peak shape we call form is Gaussian, purely Gaussian shape. Amplitude here is almost 3 to 4 to 3 ratio. The width, full width half maximum for the Gaussian, you can see about 1.9 and 1.8. The binding energy specified here, kinetic energy corresponding. So this is the parameter for the Shari background. If you also can choose the Togard polynomial, Victorian arctagen for the X-ray absorption spectrum fitting, sigmoid for the film edge fitting, carbon cage some preset for the carbon cage analysis. Also, you can click here, ABG mean active background method. Also, you can combine polynomial with Shari, polynomial with Toggle, and some other configuration also available. So this is the number of peaks. Now we choose the 2 peaks because we have specified 2 elements for 2 peaks. One element has 2 peaks for this energy range. If there is a chemical shift inside, you can also increase 4, something like this, and you can fit the peaks. And this is the corresponding reduced chi-square. If you also want to limit the energy range in the binding energy scale, and there is some parameter here. So the sensitivity factor, relative sensitivity factor RSF, beta asymmetric parameter here from the database, and the peak area here. This area normalized with the sensitivity factor here. And the N area is some, we consider the path energy, grating, mean free path, AB coefficient, and the angle between the polarization of the incident light and the emission angle. So all correction included the relative sensitivity factor consider to normalize this parameter so for considering the peak area for comparing with the other system. If you want to change the Gaussian shape to be the convolution of the Gaussian and Lorentzian, you change the GL peak, number of peak, something like this. You can also fit. You just continue. It's not really reasonable. That means these two peaks consist of just two peaks. Sometimes difficult to fit the peak because it's the parameter is out of the optimized range, so you have to manually adjust the position and width. Yeah. So it's almost okay, so easy to fit. But now it's the peak form is the Gaussian-Lorentzian convolution. It's taking time rather than the Gaussian single peak. So the shape represents the mixing ratio. 0 is purely Gaussian, 1 is purely Lorentzian. 0.08 means 92% of the Gaussian and 8% of Lorentzian mixing. The second peak is higher Lorentzian contribution,